Hi, my name is Manasseh Ephraim, and in this video we will see an integration technique known as integration by parts. If you have noticed, the integration U substitution is a reverse process for the chain rule of the derivative. This one is the reverse process for the product rule of derivatives. And now I'm going to start with a function h of x, which is a product of two functions f of x and g of x. And if we differentiate this function h prime of x, that will give us f of x times g prime of x plus g of x times f prime of x. You may have learned it in reverse order, but that doesn't matter because it's the same, it's addition. And I did this on purpose, you'll see in a minute. So I'm going to reverse this now and do the antiderivative. In other words, I'm going to integrate the function f of x times g prime of x plus g of x times f prime of x with respect to x. And because this is the derivative of h, the antiderivative of this expression becomes h plus c, h of x plus c, which equals f of x times g of x plus c. In other words, the integral of f of x times g prime of x dx plus the integral of g of x times f prime of x dx equals f of x times g prime of x plus c. And now, just for an observation, if I have this function, if I call it u, let's let this be u, we see that this is its derivative du. Okay, f prime of x is the derivative, so f prime of x dx is the differential du, and this is u. Okay, now if I let this be v, this becomes dv, and this is v. So what I have now is the integral of u dv plus the integral of v du is uv plus c. Okay, or if I bring this to the other side, what I have is the integral of u dv equals uv minus the integral of v du plus c. Well, I'm going to ignore this integration constant for now because, as you can see here, I have an integral to do. So if I integrate this expression, it will give me an integration constant anyway. So I will box this formula here. That's my formula for integration by parts. Okay, I'll be using this formula for integration by parts, but I will erase the plus c here. Okay. Alright, so let's have an example on integration by parts. Let me put the formula up here so we will see it as a reference. So the integral of u dv is uv minus the integral of v du. Okay, that's all we have. And as an example, let's compute the integral of x times sine of x. Sine of x dx. Well, this is going to look like u times dv. This is going to look like u times dv. So let's let u be x. Once we choose u, we have no choice for dv, and dv will be that one. We don't choose dv, we will be forced to have dv be the rest of the expression in the integral. Okay, so, and also that once we have u, du is just simply differentiate u, which is 1 times dx, and v is the antiderivative of sine x, which is negative cosine of x. and I'm not going to do a plus c here, the same thing, because it will complicate things and it won't contribute to the integral. We don't get a different answer whether we have a plus c or not. It will be the same answer, but it will complicate the process. So now the integral of x times sine of x dx, which equals the integral of u, this is dv. Our formula says integral of u dv is uv minus the integral of v du, which equals u is x, v is negative cos x, minus v is negative cos x, and du is dx. I'll simplify this, clean it up a little bit. This is minus of x cosine x, minus minus gives me plus of the integral of cosine of x dx, which equals minus x cos x, and you integrate cosine x, you get sine of x plus c, and that's the answer. We're done. So the integral of x sine x dx is minus x cos x plus sine x plus c, and the formula we used is this one. The integral of u dv is uv minus integral of v du. Well, that's it for now. I will have another video for a second example of this. Thank you. Goodbye.